Practicing sorting kata from episode 24 cleancoders transformation priority premise. And we begin with empty list. Just fail. And we make it pass with constant. Next we use one item element list. And let's make it pass with view transformation. First one. Sorted. I like it's constant. Okay, but now the first test failed, which is empty list. So I guess we have to split the flow. And pass. The next test is introduce will force me to introduce variable. So I will extract this magic number as a variable first. I'll call it first element. And the first element is list.get here. And pass. The next test is a few more elements. Two elements, sure. And fails. Let's just try to copy lines, except this will be second element. And it fails. Where exactly? Yeah, because we sometimes don't have that much elements. So I can split the flow again. and pass three elements. Only one. Well, I was hoping for at least two, so let's fix this. And now let's actually, I think it's time to go from if to while, but let's do some preparation first. And pass. So let's clean it up a bit. We can do this, so this. I think we good now is list collection, except maybe let's clean it up a bit more because it's second element. What is it? But it is no longer second, it's current. Pass, okay, first element, then the rest of elements. Is that actually interesting? So we might take this one and put into loop 2, but let's keep it for a sec. The next test, I think we're ready to try and sort something. Let's start with two elements. It fails as expected. And interesting that this is exactly the same line, except this is already sorted, this is not sorted. Basically, the difference is that the first element is smaller than second. This first element is greater than second. Or in other words, second element is greater than first, and the second element is smaller than first. So the second element is current element, which means all remaining element, and the first element still the first element. So let's actually reveal this intent first. Under the green. So what we need to do is collect the smaller elements. then collect the greaterElements. Okay, so here what we're actually doing here is we're collecting greaterElements. So, which literally means if current element greater than first element, okay, so this is okay, so we're adding the greaterElements into sorted. Let's actually split it into two steps, because this one does two things. It collects greaterElements and adds them into sorted. So let's actually first collect greaterElements. Add them all to sorted. Look, this is quite interesting. So here we collect first element and then add it to sorted. Here we collect greaterElements and then add it to sorted. Okay, cool. I think we might be ready for this one. Or maybe not. Oh, this is because there's no greaterElements, so we only got, so we added first element, which is 2, there's no greaterElements, so we didn't add anything. And what we actually missing here is a smaller element. And the small elements go first. Oh, okay, it's not like this variable, so let's keep it I. This will be n. Okay, and it pass. So, but we need to clean up for sure. So let's maybe, so this is like two action. One is collecting elements, another is adding elements. So let's actually do it like this. Okay, pass. And now I believe all we have to do is join these loops. Can pass, and we could so small. Alright, so okay, so basically we got an algorithm. Okay, but I think there's more tests which will fail. So before we go, let's try 2, 1, 3. And pass. So 2-second elements in order pass. So let's look into the cases where remaining elements like out of order. Like so, this is case where smaller elements are out of order. Means this first element and this smaller element, so they go here, but they are out of order itself. So it should fail. Yes, 2 and 1, 3, which we can, so smaller elements, so we can fix it with recursion. We can make it work with recursion. And another case is when big elements out of order, like greaterElements we call them. Here and just do the same here. Okay, that should be it. Let's do a test with big list. I'll just copy the function. $50,000. Curly pass. So we can clean up a little bit. And it works. So I think, yeah, looks like the same algorithm. Quick sort. So collect first element, then for loop through all remaining elements. Check if current is less than first element, add to smaller group elements. Otherwise, assume it's greater and add current element to greater group. Then add smaller before first one and add greater after first one with recursive sorting.